Let's talk about composite figures. Composite figures are when you take more than one shape and you push them together to make one ugly shape. Now, in order to think about the area for composite figures, we need to remember the area for all figures. So here's a quick refresher for rectangles, parallelograms, rhombuses, trapezoids, and triangles. We could shove any of these or all of these into one figure and find the area. I guess one that is missing from this is the area of a circle, which will be incorporated into some of your work. Area for a circle is pi times your radius squared, where your radius is that distance from the center of the circle to the outside of the circle. Oh, here's where that comes into play. So I have two shapes here. Pretty obvious. I've got half of a circle and I've got a square. So I know a square, the area of my square, is going to be equal to a side squared. And my area for my circle, I'm going to take 1/2 of that because I only have half of a circle. I don't have like more circle overlapping here and I have double area in this. We don't want to do that. And that's going to be pi, our radius squared. Well, we know all the way across is 6, so my radius is 3, so I'll be 3 squared. Oh, I should probably put in my side length here is 6 squared. And once I find these two values, I'm going to add them together. So 6 squared is 36. 1/2 pi 3 squared is 14.1371 blah, 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 blah. We're just going to round. So let's add those together. We'll get 50.13715, blah, 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 blah. We'll round to the nearest hundredth. So the 7 will make the 3 round up. So we'll have 50.14. And in this case, we're working in yards squared. All right, here's a composite figure. Now, in this case, what do we have? It looks like we don't have a square or a circle. In this case, we have a rectangle and a triangle. Maybe I'll start labeling as I find my areas. So I want to find the rectangle and I want to find the triangle. Now, the rectangle, that's area is equal to base times height. My base in this case is 5, and my height in this case is 8, or vice versa. That's going to give me 40. Now, triangle, it's 1/2 base times height, so it'll be 1/2. My base in this case is 8, and my height in this case is 5 again. Notice I'm not using that 9.4 yards because that's not really giving me anything. Your height and your base are always perpendicular to each other. So that's going to give me 20. Altogether, that'll give me an area of 60. Again, this one's dealing with yards squared. Now, that's what happens when you have two shapes. What if you have something with more? Ooh. However, don't be intimidated by this shape. There's just a bunch of shapes pushed together. You can find the area of each piece individually. Now, one thing you might have to keep in mind is which shape you're working with. I'm going to go ahead and work the area for each shape within the shape itself so I can kind of keep it organized. So I'm going to look at this shape first. And that, to me, looks like a rectangle. It is a rectangle because I have right angles. So rectangle is base times height. So 6 times 10 gives me 60. Okay, I'm just going to kind of keep a running total here of my areas. Okay, and then I have this nice triangle. Triangles are 1/2 base times height. In this case, our base is 10, and our height is 8.7. So 1/2 times 10 times 8.7 is 43.5. next thing we need to come across is this triangle. And again, I'll use that 1/2 base times height. I'll have 1/2. My base in this case is still 10. My height is 6. That's going to give me a total of 30. Okay, last shape. Well, this is not a trapezoid. Oh, this is a trapezoid because we have the 2 right angles happening here. So we have 2 bases. We have a height. So we need to fill in that 1/2 height times the sum of your bases. Well, your height in this case is 6, and your bases are 6 and 10. Now, why don't we use the slant height? Remember that you always want to use that height that forms a right angle. So we have 1/2 6 times the sum of 6 plus 10. That's going to give me 48. Okay, so once I've found the individual areas of all of my shapes, I can add them together. This is going to give me 181.5 meters squared. And that's the area of this figure. And this was kind of nice because they split it into the shapes for us. What if they don't? So I'm looking at this figure, and this figure isn't split up into individual shapes. So I have to decide, how am I going to split this up? Now I'm going to split this up into those 3 shapes because I know what this little rectangle here, I can do base times height, which is 4 times 5, and that's going to give me 20. And I'm having some difficulty seeing that. I'm going to switch colors here. So I know I'm dealing with 20 plus, okay, let's find the area of this rectangle. Now, I noticed that this side is going to be congruent to this side, so that's 4. And so I could do 7 plus 4 plus 7. But if I did that addition, I would get, I would get that whole distance, which is, what is 7 plus 4 plus 7? That's going to give me 18. Cool. So I'll have 4 times 18, which is going to give me 72. Still having some trouble reading that. Let's go brighter. Now we have our last piece is this triangle. Now, if I know that this height right here is 4, that means this is 4. And if this whole distance is 8, that means the height of my triangle is 4. Now, we just said that this distance was 18 all the way across. And we know all the distance except for the distance covered by the triangle is 15. Then that'll give us the base of our triangle, which is 18 minus 15, which is 3. Now I can do 1/2 base times height. So 1/2, I don't have space inside my triangle to write this. 1/2 base, which is 3, times height, which is 4, which is 6. So I have an area inside my triangle of 6. I can now add all those up. 20 plus 72 plus 6 is 98. And in this case, we're dealing with centimeters squared. This one looks especially messy. That's okay, we'll figure it out. Now, the first thing we should probably figure out is how we want to split it up. Now, I see this quarter of a circle here. Now, I feel like that's going to be the most complicated piece of this problem. I know it's going to be 1/4 pi r squared whenever I solve it, but I need to figure out that radius. That's probably going to be the tricky part for me. So I'm going to focus on that first. Now, as I'm looking around this shape, I don't see an immediate way to do that, so I'm just going to start solving things and hoping that the solution will present itself. I know I can split this square off, so that's 9 times 9. This is going to give me 81 inside there. Now, if I cut off 9 on each side, then there is 12 left for a height here. Okay, that's going to actually be very useful for me because that means I can say that this whole rectangle is 12 tall by 39 meters. So 12 times 39 is going to give me the area inside here. And that's going to give me 468. I need to write that a little bit darker. Which, as I solved that, something occurred to me. I want you to follow along very carefully here. So if this whole distance across the entire shape is 39, actually, is that the case? Let's see. The only way I would double check that is I would add up the pieces all the way across. And if they equal 39, then I know that the 39 was talking about this whole distance, but I'm thinking it's possible the 39 might have been only talking about this distance. Let me figure that out. 12 plus 9 plus 12 plus 21. Ooh, that's 54. So this whole distance is 54. Which actually makes this area 648. Now that we know that this 39 is just talking about this section, we actually have a way to solve for our radius. Let's talk about how. Well, we know this whole distance all the way across. That whole distance, we just said that was 54. Well, we know this section of it is 39. And we know this section of it, based on this, is 9. So if we take 39 and 9 away from 54, we're going to be left with 6, which is fantastic because that's the radius of my quarter circle. So we can do 1/4 pi times 6 squared. And in this case, it's telling us to use 3.14 for pi. And that's going to give me 28.26. Okay, let's solve for another piece. What's left? We have these two top rectangles. This one is a square, actually. It's 12 by 12. Well, 12 squared is 144. So I'll add that up over here, plus 144, plus 12 times 15 for my base times height is going to give me 180. Now I have all the pieces of my composite figure. I can add those together. And that's going to give me 1081.26, and this is in meters squared. Oh, it says nearest tenth. So I actually need to look at that 6, and we'll make the 2 round up. So it'll be 1081.3 meters squared. And that's our final example. Good luck with composite area.